All right, so closing in on the end of 2.4, we're 2 videos in, and hopefully this will cover everything. We did parallel lines in the last one, which means we need to talk about perpendicular lines here. Parallel lines, right, were two lines that have the same slopes and they never intersect. They're sort of moving in sync, and they never cross into each other. Perpendicular lines are the exact opposite. They're lines that sort of create 90-degree angles, which I attempted to draw here, but it's not perfectly square. That is, they're sort of directly running into each other. If you think of a four-way intersection, not in Boston, of course, because all the intersections here are wild, but a more typical intersection from another part of the country where the roads don't just like go every direction you could possibly imagine. A city on a grid, perhaps. We can dare to dream. In any event, the idea with the slopes of perpendicular lines is they're sort of running directly into each other, and so they have the opposite slopes. And when we say opposite here, what we specifically mean is the negative reciprocal. So the relationship is you're sort of doing the negative version of the other slope and you're flipping it upside down. So it's kind of 1 over the negative value. For instance, I think this is easier if we just sort of see it with an example. So something like positive 2/3 versus negative 3/2, right? You've kind of flipped it over and you've changed it from positive to negative, or something like -2 versus positive 1/2, right? -2 would be like a -2/1, so flipped it would be 1/2, and it flips from negative to positive. So perpendicular lines have opposite slopes. You're sort of on purpose creating lines that are going to run directly into each other. They couldn't disagree more about what direction that they should be heading and the kind of steepness and direction they have, right? Positive, negative, and sort of opposite steepness. What this is going to mean for us is if we're trying to find an equation for a line perpendicular to, excuse me, something like y equals -1/3 x minus 2. We want an equation that's perpendicular to that and goes through the point -2, 4. So what I need here, as always, I need a slope and I need a point. I almost have a slope, right? There is a slope that I'm given, which is this -1/3. I need a perpendicular slope to this, however, right? So I need the opposite slope. I'm going to flip it, and I'm going to flip the sign. So negative to positive and 1/3 to 3/1. So my new slope is going to be +3. 3/1 we'll just think of as +3. So my line is going to have slope 3, and it's going to go through the point -2, 4. Okay, so into point slope form, we've done this in almost every video from these two sections, so hopefully this is second nature at this point. Subbing in our numbers, y minus 4 equals the slope 3 times the quantity x minus -2, right? -2 and 4 coming from the point up there. Clean it up. Y minus 4 is 3 times the quantity x plus 2, right? Minus 2 is x plus 2. That would be the point slope form, right? That is the form. That's what we would use. That's what we would sort of put in as an answer for that, that question, if that's what we're asking for. The slope-intercept form, right? Of course, as always, taking that, expanding it, and solving for y. The slope-intercept form is, so y minus 4, 3 times the quantity x plus 2, would just distribute. 3 times x plus 2, 3x plus 6. So y minus 4 equals 3x plus 6. From there, to solve for the y, all I'm doing is I'm adding 4 to both sides, right? +4 plus 4. Y equals 3x plus 10. And that's a bingo, right? That's the end of it. That's the slope-intercept form. We could make a graph from there starting at 0, 10, right? Up 10, and then we're going to move up 3/1. It probably would have been cool to draw a picture of these two lines intersecting, but honestly, I ran out of space, and I didn't want to try to make another page. So I leave that to the listener. That is an exercise for you. Make a couple graphs here and see these two lines intersect. go. In any event, so that's perpendicular lines, and that's really what we're taking away from section 2.4, parallel and perpendicular. There we go.